Hi everyone, welcome to Unit 2, Lesson 4, Grams and Moles. Today, what I hope to show you is how to convert between grams of a substance and moles of a substance, or a unit that we use in order to calculate quantities of material that we could weigh out on a balance in a lab. So let's get started. We're going to begin by looking at 4 different definitions. So the first definition is what we've been using to talk about the masses found on the periodic table, and that is atomic mass, or the mass of a single atom in AMU, or atomic mass units. Moving forward, we're not going to be able to practically weigh out individual atoms or even molecules because they're far too small. So instead, we'll be using much larger quantities, and we'll talk about those quantities in our lessons next week. For now, I want to go over 3 additional definitions. So the first is molecular mass, or the mass of a molecule in grams per mole. Now, this is often misused to talk about things that are not molecules. By definition, a molecule is a substance that is composed of 2 nonmetals, or 2 elements, as shown in the picture, that are found all the way on the right side of the periodic table. The same can be said for formula mass. This refers to an ionic compound. An ionic compound is composed of a metal and a nonmetal. Metals are found on the left side of the table. Nonmetals are found on the right side. So in order to use the term formula mass, you would need a compound consisting of 1 metal and 1 nonmetal. I prefer to use the universal term molar mass. Molar mass is the mass of any substance in grams per mole, regardless of whether it comes from the left side, the right side, or both from the right side. You can use the term molar mass. So the first thing that we would like to do is to figure out what our molar mass is going to be. In order to do this, you will need a periodic table with the masses on it. One can be found in the Lesson 4 folder. So let's begin by looking at our first example, sodium chloride. At this point in the course, you are not expected to be able to name compounds. So for any of the compounds we will be using, I will provide you the name. Or if I provide the name, I will also provide the compound, the formula for whatever substance we are talking about. So if you find on your periodic table the element sodium, you will find it has an average atomic mass of 22.99 grams per mole. We are going to round all of our masses to 2 decimal places. So any mass that we find on the periodic table will be recorded in our work with 2 decimal places. Let's do the same thing for chlorine. If you look up chlorine on the periodic table, you'll find out its mass is 35.45 grams per mole. Adding these together, I will get the molar mass for sodium chloride, which turns out to be 58.44 grams per mole. We are now going to look at a second substance, sodium sulfate. This is also a great time to remind everyone of the importance of these subscripts and their meaning. When we see a subscript of 2 after the sodium, that means we have 2 sodium atoms. When we see this subscript of 4 after the oxygen, that means we have 4 oxygen atoms. The 4 does not belong to sulfur, only to oxygen. So we will begin by looking up the molar mass for sodium. Again, 22.99 grams per mole. This time, we're going to multiply by 2. We will then look up the mass for sulfur, 32.07 grams per mole. And finally, the mass of oxygen, 16.00 grams per mole. And that will be multiplied by 4. Once again, I will add up all of these to get the molar mass. So 22.99 times 2 plus 32.07 plus 16 times 4, and I get a molar mass for sodium sulfate that is equal to 142.05 grams per mole. In our next example, we have copper 2 nitrate. So in this case, I want to remind everyone of the significance of parentheses. If you have a subscript outside of the parentheses, it gets distributed throughout the parentheses. So for copper, there is no subscript. So copper has a mass of 63.55 grams per mole. The nitrogen in the parentheses means that I have 2 copies of nitrogen. So nitrogen is 14.01 grams per mole. That will need to be multiplied by 2. And finally, for oxygen, we will have 2 times 3, or 6 oxygen atoms. So we will take the molar mass of oxygen, 16.00 grams per mole, and multiply that by 6. Adding these together, we get 63.55 plus 28.02 plus 96, or 187.57 grams per mole. If you're still unsure about how to use the parentheses, it may help to draw a picture. So in this picture, we would put copper in the center, and NO3 would look like this. Obviously, I don't expect you to be able to make these drawings yet, but I wanted to draw it out so that you could see what that means. So the 1 copper is represented by copper right here. The 2 nitrogens are represented by nitrogen on the left and nitrogen on the right. The 6 oxygens are represented in groups of 3. So on the left side, we have 1, 2, 3, and on the right side, we have 4, 5, 6. Let's take a look at our last example. Our last example is known as sulfur trioxide. Sulfur on the periodic table has a mass of 32.07 grams per mole, and oxygen has a mass of 16 grams per mole, but that will need to be multiplied by 3. In this case, we're going to get an answer of 80.06 grams per mole. Okay, that's how you figure out molar mass based on the average atomic masses available to us on the periodic table and the chemical formula. Next, we're going to use these molar masses in order to make unit conversions between grams and moles. Okay, in our first example, we are asked to convert 264.93 grams of copper 2 sulfate into moles. So the very first thing that you need to do with all of these problems is find out your molar mass for the substance that you're dealing with. So in this case, our example is going to have copper sulfate. So the molar mass for copper is 63.55 grams per mole. The molar mass for sulfur is 32.07 grams per mole. And our molar mass for oxygen is 16.00 grams per mole, which will be multiplied by 4. We are going to add those numbers up, 63.55 plus 32.07 plus 16 times 4 to give us a grand total of 159.62. The next part is going to look very familiar to us. If you think back to what we did when we were looking at metric unit conversions and at English unit conversions, we're going to apply that very same method to what we're doing today. So in the first unit, I told you that we were learning how to do this skill so that we can use it later. We're going to begin using it right now. So we're never going to really worry about converting days to hours to weeks or anything like that, but we're going to use those skills that we learned back in Unit 1 to convert between grams and moles, and eventually between grams and moles and molecules and atoms and all sorts of other good stuff. So let's take a look. We're going to begin with the information that's presented to us in the problem. We have 264.93 grams of copper 2 sulfate, so CuSO4. We're going to put that right here. In all of the problems that we are doing on today's assignment, we are only doing one conversion, either from grams to moles or from moles to grams. So one conversion only, which means I'll do times and then align just one line. In this case, we have 264.93 grams on top. That means in our fraction, grams have to go on the bottom. This is how that's going to work. We're going to use the information from our molar mass. When we write out 159.62 grams, what we really mean is 159.62 grams equals 1 mole. So we have to decide if we want grams to cross out, then we're going to put the grams on the bottom and the moles on top. If we wanted moles to cross out, then we'd put moles on the bottom and grams on top. In this example, we want grams to cancel out. Now, when we're doing our problem, you want to make sure to always include 3 parts: the number, the unit, and the substance. So from this point in the class forward, anytime we write a number, we're going to always associate a unit and whatever substance we are talking about. So you'll see it in all 3 cases here: number, unit, substance. Number, unit, and our substance. Okay, remembering what we learned back in Unit 1, if we have a number on the bottom of our fraction, we're going to divide by that number. So into my calculator, I'm going to type 264.93 divided by 159.62. That turns out to be 1.65975. I'll write out all of the digits. Now, we obviously cannot keep all of these digits, so we're limited to 5 significant figures, so our final answer will be 1.6598 moles of copper sulfate. And it's a good idea to put a box around your answer, or I've been noticing students highlight their answer in yellow, which is excellent. I also want you to notice how the units cross out. So grams of copper sulfate cross out with grams of copper sulfate. Let's take a look at a second problem. In this problem, we will be converting from moles into grams, so the opposite direction of what we learned. The first thing that we need to do, just like last time, is to figure out the molar mass of sodium carbonate, Na2CO3. So the molar mass of sodium from the periodic table is 22.99 grams per mole. We're going to multiply that by 2. The molar mass of carbon is 12.01 grams per mole. And the molar mass of oxygen is 16.00 grams per mole. And we will multiply that by 3. We're going to get a total mass of 22.99 times 2 plus 12.01 plus 48, 105.99 grams per mole. Remember what this means. 105.99 grams of Na2CO3 equals 1 mole of Na2CO3. Next, we're going to begin with the number that we are given, 2.51 moles of Na2CO3. And remember that today's examples will only have one conversion from grams to moles, or in this case, moles to grams. So if we look at this piece down here, we will realize that this problem, we're going to put 1 mole on the bottom. So down here, we will have 1 mole of Na2CO3, and on top, we will have 105.99 grams of Na2CO3. Notice number, unit substance, number, unit substance, number, unit substance. Every time, it's important. 2.51 times 105.99 turns out to give us an answer of 266.0349 grams of Na2CO3. However, we are limited to just 3 significant figures, so our final answer is going to be 266 grams of Na2CO3. So I wanted to do my third example as a shared screen, so you could see exactly what it should look like as you type it in. So for the first part, we have Na3PO4, our sodium phosphate. So I'm going to take 22.99 grams per mole of sodium, multiply that by 3. And to that, we're going to add our molar mass of phosphorus. So that's 30.97 grams per mole. That's times 1. And finally, our oxygen, which is 16.00 grams per mole, and we'll multiply that by 4. I'm going to make a little line here to make it look like a nice, neat addition problem. And let's add those together. So we have 22.99 times 3 plus 30.97 plus 64 for the 4 oxygens. We get an answer of 163.94. next part you don't have to write out, but I just wanted to remind you, we have 163.94 grams is equal to 1 mole of Na3PO4. It's a lot to subscript and superscript. So what I'm asking you to do is you can copy and paste this term in the Google Doc and use it whenever you need it. So if I copy it here, I can paste it here, and I can paste it over here. Now I'm ready to set up my problem. So what I would like to start off with is the 4.50 moles. Now I can paste my Na3PO4 again. To get out of the subscript, hold down Control and hit the comma. That'll bring you up to the regular size font. So my conversion should take place over 3 different lines. So here's my first line. My second line is going to be times, and then our dotted line like this. And then at the end of that, we can put an equal sign. That's where we'll put our final answer. In this case, since I start off with moles, I want moles to be on the bottom. So on the bottom of this fraction, I'm going to write 1 mole and then Control paste my Na3PO4. And then on top, I'm going to write 163.94 grams. And again, paste my Na3PO4. You can move things around to make them nice and neat, and I would appreciate it greatly. Finally, to get your final answer, we're going to multiply because both things are on top. So we have 4.5 times 163.94. And we wind up getting an answer of 738, because we're going to round to the third significant figure, 738 grams of Na3PO4. If you really want to impress me, you can show how the units cancel out. To do this, select the part that you want to cancel out, hold down Shift, Alt, and hit the number 5. Shift, Alt, and the number 5. That'll draw a line through it. And the same thing with this unit down here. Shift, Alt, hit the number 5, and that'll draw a line through it. And you can actually show me how the units cross out. Okay, that wraps it up for this session. I hope everyone has a great week. You have 5 homework problems to complete for me. Please make sure to follow the exact format that I show you in the video. If you don't use 3 lines to show your conversion, the maximum amount of points that you will earn on your homework assignment is 5 out of 10. Please, I'm begging of you, please follow the method that I showed you. If you have any questions, please stop by one of the online extra help session Zooms, which can be found on the Schoology website. Thank you. I hope you guys have a great week. See ya.